Everyone, a very good evening to all. Now we are going to study the question number 82, that is all about capillary rise. So what is capillary rise and what are the things we should know about it? So the very first thing what we have to understand here is what is excess pressure. So in case of liquid drop or bubble, so any bubble like air bubble or soap bubble, when you consider, there is always excess pressure inside it. So first you consider liquid drop or air bubble. So liquid drop means inside air bubble means inside liquid. When you consider, there is always greater pressure than outside, and that pressure difference is called excess pressure, and that is given by 2T by R, where T is surface tension and R is radius. And in case of soap bubble, there are two surfaces. That's why here excess pressure Pi minus P naught will become 4T by R. This is what the excess pressure inside a soap bubble or liquid drop or air bubble. So always there is an excess pressure inside the drop or bubble so that it blows off. That is what the concept called excess pressure, and how much it is equal to. You should know the difference between drop and bubble properly. Now, how to compare excess pressure inside to drop or bubble? When you consider excess pressure, either 2T by R or 4T by R. When you consider 2, like of radius R1 and R2, having pressures P1 and P2, and outside pressure is P0, then P1 minus P0 by P2 minus P0, that is delta P1 and delta P per second 1 equal to T1 by T2 times R2 by R1. If same liquid, then T1 equal to T2. Then delta P1 by delta P2 equal to R2 by R1 implies volume V1 by V2 equal to R1 by R2 whole cube equal to delta P2 by delta P1 whole cube. So like that, comparison based questions they can ask based on the excess pressure between two drops or bubbles. Now the next thing is what is angle of contact and capillary rise. So when you consider, see here, there is a tube and narrow tube actually, and you put it inside the beaker having some liquid. Now what can happen is the liquid may rise up to some height, the liquid may drop up to some depth. So that is called capillary action. Rise or fall of liquid through a narrow tube. Narrow means very narrow. It is like diameter equivalent to our hair. That much narrow tube. Then that H formula is given by 2T cos theta by R rho G, where T is surface tension, R is radius of the tube, rho is density of the liquid, and theta is called angle of contact. Angle of contact means when you take the liquid and solid in surface, draw a line parallel to liquid surface and draw a line along the solid surface which is inside the liquid, then that angle is called angle of contact. And here this one is, and this one, so this is theta. So here theta greater than 90, here theta less than 90, and here adhesive forces are greater than cohesive forces, and here cohesive forces are greater than adhesive forces. So when cohesive forces are greater, the liquid will fall. When adhesive forces are greater, the liquid will rise. So when theta less than 90, or you can say in another way, when a liquid surface wets the solid surface, then theta less than 90. When the liquid surface, and when the liquid does not wet the solid surface, then it is called theta greater than 90, cohesive forces more. Just like you take some mercury in your hand, it will not wet your hand. That is what? The angle of contact and the capillary rise. And what are the special cases of capillary rise? See, when you consider this is the beaker and this is the liquid, now you take one. Here there is some height increased. Now height formula we have. Now suppose you keep this like this. Then also it rises to the same height. But what got changed? Length. Now you are keeping the tube at an angle theta, so that here if you take sin theta equal to h by L, then L equal to h by sin theta, where h is same as 2t cos theta by r rho g. And suppose if they are asking what is the mass of liquid rises, then mass equal to volume into density. So volume means cylindrical shape. So pi r square h into density is rho. So h value if you substitute, then you will get the answer. So this is how they can ask. Also sometimes they can ask if length is not sufficient, length is not enough. So the length above the liquid surface is lesser than the liquid can rise. Then the liquid will not overflow. It will adjust its radius such that H1R1 equal to H2R2. So that is what the different things they can ask based on the capillary rise. Let's see few questions based on whatever we have studied. Now here is our first question, that is water rises to a height of 10 centimeter in a capillary tube, and mercury falls to a depth of 3.42 centimeter in the same capillary tube. If the density of mercury is 13.6 kg per meter cube and angle of contact is 135, the ratio of surface tension for water and mercury is, see, H equal to 2t cos theta by r rho g. Now, angle of contact, see, one is water and another one is mercury. Now here we take it like H1 by H2 when you consider T1 by T2 times cos theta 1 by cos theta 2 times R2 by R1, rho 2 by rho 1, G will get cancelled. Now water rises to a height of 10 centimeter in capillary tube. H1 they have given. H1 is how much? H1 is 10 centimeter. H1 is 10 centimeter and H2 is 3.42 centimeter, but drop means you can take it as minus. And density of mercury means rho 2. So rho 2 is 13.6 gram per cc you can take. No, kg per meter cube. No, actually it is gram per cc. Okay, let it be. They have given wrong. Rho 1 equal to 1 gram per cc. Anyhow, it will get cancelled. And angle of contact, theta 1. Sorry, for mercury they have given as 135 degrees. And theta 1 for water and glass they have given as 8 degrees. Then what else we want? Tube of in the same capillary tube. Now same capillary tube means radius gets cancelled. So now they are asking the ratio of surface tension T1 by T2. But here one thing, 8 degrees is there, cos theta. So cos theta is very small. You can take theta approximately 1. No problem. Cos 0 is 1. So then you will get the answer. Approximately you will get the answer, not an issue. But usually when they give this kind of random values of angle, they should give the data and they will give the data in the question, so that you can calculate this ratio T1 by T2. Remaining every data they have given. Now, next question. A glass tube of radius 0.4 millimeter is dipped vertically in water. So radius is 0.4 millimeter, nothing but 0.4 into 10 power minus 3 centimeter. Find up to what height the water will rise in the capillary. So height means again 2t cos theta by r rho g. Okay. and the tube is inclined at an angle 60 degrees with the vertical. How much length of the, so length equal to h by sin theta, I said it already. Surface tension they have given T equal to 7 into 10 power minus 2 Newton per meter, and density they have given 10 power 3 kg per meter cube. And so you take theta, they did not mention. For water and glass it is approximately 0. So cos 0 is 1. So all the values they have given. Then you can substitute and calculate it. Now, a capillary tube whose inside radius is 0.5 millimeter, again radius they have given 0.5 into 10 power minus 3 meter. Sorry, here I made it mistake. Meter actually is not centimeter. Please correct it. And dipped in water having surface tension. Surface tension is 7 into 10 power minus 2 Newton per meter. So again, almost similar question, only thing radius got changed, density is same. So again, you have to apply 2t cos theta by r rho g. And again, here they mentioned clearly the angle of contact is 0 degrees. So they can give any liquid, any solution, anything, you have to take care. Now the next thing is surface tension of soap solution is 25 into 10 power minus 3 Newton per meter. The excess pressure inside a soap bubble of diameter. Now they are asking soap bubble. So delta P equal to 4T by R. And surface tension they have given as 25 into 10 power minus 3 Newton per meter. And radius is 1 centimeter, nothing but 10 power minus 2 meter. So just direct question, just substitute it. 4 into, only thing you have to take care that it is soap bubble, so you have to take the formula 4T by R. So 100 and this goes up means 10 power minus 1, so it will become 10 Pascal. Now one last and final question. A soap bubble in vacuum has a radius of 3 centimeter and another soap bubble in vacuum has a radius of 4 centimeter. If the two bubbles coalesce under isothermal condition, then the radius of the new bubble. Under isothermal condition means P1 V1 plus P2 V2 equal to P into V, where P1 means pressure inside the first soap bubble, that is P naught plus 4T by R1 into 4 by 3 pi R1 cube. P2 is P naught plus 4T by R2 into 4 by 3 pi R2 cube equal to P is the resultant one, P naught plus 4T by R into 4 by 3 pi R cube. See here, under inside the vacuum they are telling, so there is no atmosphere, P naught is 0. So if you calculate, then it will become 4 by 3 pi, 4 by 3 pi, 4 by 3 pi cancel. P naught, P naught, P naught will become 0. 4T, 4T, 4T will get cancelled. R1, so R1 square plus R2 square equal to R square. This is the general formula. If there is no vacuum, generally, then you can take volume remains constant. But if this is isothermal condition in vacuum, they said, so you have to take like this. So that R square will become 3 square plus 4 square implies R will become 5 centimeter. You can remember this like a formula also. Now similar questions I have given as an assignment. So just try to understand and try to solve so that you will get the idea how to solve the questions. So thank you all. We'll continue in the coming session with the next question.